Hi, my name is Mark Ryan. I'm going to walk you through building custom Zscaler app connectors for Zscaler Private Access and provisioning these programmatically on AWS EC2. So I'm on the development cloud. I'm going to be using some development APIs that will go into production in a future release. But the premise of this is we will programmatically deploy app connectors in a kind of a DevOps environment. So let me run through the script here. The script is going to mount a file system on an AWS instance, and then it's going to build the latest version of Centos in there. And as part of that, it will harden it and set some base system parameters, and then install some tools, the AWS tools and things like that we're going to use AWS resources to pass system parameters down there. Got a couple of hardening scripts here. We've also increased the ephemeral port ranges so we get better performance out of the connectors, and standard configurations. So before I do that, what I'll actually do is I'll just show you this in EC2. So it is an actual EC2 instance that's running my build script, a T2 micro. And what we'll do is we'll actually kick off that build process. So it's going to look at the current date and time, and that's what it's going to use as the naming convention for my connector. It sees which zone I'm in, which region I'm in, which is necessary for it to be able to take the snapshots and build the AMI. So this is going to go off and do that. It's going to take a little bit of time to mount the volume, then it'll go off and do the install, and it'll take a bit of time, and then it'll snapshot that volume and create the AMI. So all in all, the actual build process probably takes, it's less than 10 minutes end to end. So we'll get that going, and then I'll continue going through the script and the setup in the environment. So what is this script going to do? So it's going to we've got two scripts that it's dropping in there, provision and deprovision. Provisioning script. First thing it's going to do is it's going to enumerate essentially the region that I'm in and the VPC I'm in, and the instance ID that is running, and so we can use all those variables to build programmatically the environment. So it's going to read the client secret and the client ID, and we're going to use Systems Manager in AWS to hold these parameters and pass them through to my instances. So everything's going to be held securely in Systems Manager, and we're going to use IAM roles to control access to those parameters, and we're going to encrypt those with KMS. So we're ending up pulling down tokens encrypted, and use the native AWS environment to encrypt and decrypt those parameters. So we've got the client secret, we've got the client ID, company ID, and these three things together are part of the API call. Zscaler base is essentially a parameter that instructs the AMI. Are we running in my case, the dev environment, or are we running in beta, or are we running in production? So we build up the post data, we log on, and we get our access token, and then we use the access token to retrieve the provisioning key from Zscaler, and this is part of the new API. And what we're going to use is the key, and the key here is region-VPC, as the naming convention for our app connectors. So basically what that means is, as long as we call our connector groups and the provisioning keys by a standard naming convention, then we can use that programmatically in our provisioning and deprovisioning scripts. So we go off, we get the provisioning key, and we drop it in the provisioning key file. We start the connector, it sleeps for a little bit whilst it goes through the enrollment process, and then we figure out by looking at the generated enrolled certificate for the connector, we're able to figure out what the connector ID is, and then we use that to set a tag on the resource. So EC2 instance can have, or any resource can have a tag associated with it. We're going to set a tag which is called the connector ID, so you can actually see the connector ID in AWS as well. The deprovision script basically runs the reverse of this. It stops the connector process. It reads the connector ID from the tag, and then it goes ahead and it does the same thing. It enumerates the region. It pulls out these parameters from Systems Manager, and then it does a delete, or issues a delete through the API to delete the instance of the connector, and then it removes all of the files associated that from the directory. You might say, well, do we really need to use the tags? We could always just enumerate the connector ID each time. Yeah, we could do that and avoid doing these two things. But it's useful to keep these things in the tags, and we can use them elsewhere. We could have Lambda scripts, for example, that would be able to read the tag off from the device and be able to execute things against the EC2 instance. So setting the tag is useful for us. Okay, so we've got all of that. Let's just quickly jump into the Private Access Administration Console. Let's sign in here. As I said, we're on development, so it's a very singular environment, and maybe not as stable as obviously the beta or the production environments. There we go. Okay, so let's go ahead and look at the provisioning keys. So as you can see, I created a provisioning key called USEast2-VPC EC 0C2085. So that is the region, the AWS region, USEast2 dash, and then the name of the VPC that my instances are going to running. Now, obviously, if I'm building these in my VPC in that region, I would build a pair, so I'd span that across availability zones to give me resilience. But the fact that it's in that VPC within that region means it's a location, and so a connector group should be a physical location, or in a infrastructure as a service environment, a logical region or location where my connectors are going to run, and I should make them fully resilient. So if I look in my systems manager here, I have this concept of a parameter store, centralized management of parameters that can be used across all of my instances. I can download those things. So I've got my 4 different parameters. So I've called them ZSAC dash just to give me some differentiation. So I've got my base URL. URL for dev is public-api.dev.zpath.net. In production, it's config.private.zscaler.com. So a couple of different URLs that we could use for our base, and obviously that'll differentiate our different environments. If I look at my other environment, other variables, I won't show you the secrets or anything, but my company ID, again, I can pull that out. If I look in administration and go to my company, this is the unique company identifier. Provided I clicked it, company. Like I said, it's a little slow on dev. We'll come back to that. But you'll see that these are secure strings, so they're encrypted, and they're encrypted with KMS. So if I look over here with my key management service, customer managed keys, I've got a key, this is called KMS SSM. So this is the public-private key pair that's used to encrypt parameters. And I've created an IAM user called Zscaler SSM IAM that has access to this key. So if I look in my identity and access management configuration, I've got sorry, IAM role. Here's my Zscaler SSM IAM role. It's trusted by EC2. So EC2 is the instance that can assume that role. And that role has a policy associated with it. So if we look at this policy, the policy basically says, it's not necessarily the easiest to read, so has the ability to create tags within EC2. It has the right to go to SSM and get parameters as long as the parameter is called ZS dash or ZS star. It has the ability to read the tags, and it can get access to KMS to read the keys and do everything there. So we've got all the necessary permissions, and you want to be as tight as possible on these permissions to say, okay, so it can read parameters from the specific parameters from the systems manager store. It can get the KMS keys to decrypt them, and it has the ability to read and write the tags on the EC2 instances, which was what the script was doing. And that is it. That is all we want to do with that IAM role. So that's all going ahead. Let's take a look over here. There we go. We've just finished completing the snapshot. So my talking more or less figured out the 5 minutes, 6 minutes and a little bit to actually create it. So we've registered an EC2 image. The AMI ID is here, and the name is ZPA connector, 1st of October 2021, 10:07 GMT. I'm in BST +1, which is GMT +1, and this instance was registered on US East 2. So we've now got our new instance. So if we come over here to my instances, I can launch a new instance. It's using my AMI that I've created. Here it is. So I can select that one. Maybe it's not the dev environment, maybe it's everything's running slow from my location today. My AMI, select this one, there we go. Okay, so I can run this on a T2 micro because it is very much a demo environment. Obviously you wouldn't use T-type in a production environment, and we can actually build this on more or less any instance type we want. Let's go ahead and configure the instance. So I select that IAM role, so that's going to give it the permissions to read all those parameters, KMS, read and write the tags. And I'm just going to pass it a bit of user data. So I'll come in here, it's very complex user data. User data basically says, when you start up, run the file /opt zscaler bin provision.sh, which is a shell script. So we can now go to review and launch this, and I'll pass it my key pair. Let's launch that instance. Okay, so we can go ahead and view the instances. Let's refresh this. It's going to start up shortly. Let's clear out that filter. It'll show me a couple of older ones. So this one here is initializing. We've got its DNS, so we'll copy that to the clipboard, and we'll come across here. So I can exit out of my build environment, and I can SSH -i /dot SSH /ID and RSA, and it's admin at and that EC2 instance. There we go. It's started up. This should probably say it's running, still initializing. So hopefully opt in Zscaler. So if we ls var, you can see it's already enrolled now. So that script ran, it dropped the provision script or provisioning key into it, started up the system, the ZPA service, and that went ahead and enrolled. And we can see this in a couple of different places. If I jump back over here. So if we come to private access now and go to my app connectors, we have an app connector from 1120 BST, so it's just enrolled. And it's gone ahead and connected, and we've got all that enrollment. And it's running the latest version of the software. So we've got a version of the AMI running the very latest software. It's instantiated, and we can come over here. Let's have a system CTL status ZPA connector -L. It's all up and running. Let's just refresh this. I'm not sure why it was saying disconnected. There we go. We're connected, and we're all looking good. Now, what we can do, we've decided now, if we were to do this programmatically in a CloudFormation template or an auto-scale group, we can run bin/deprovision. That'll go ahead and read that tag. Oh, probably should look over here. There's the tag. The tag is the connector ID and 29. So if we go deprovision, I'll go ahead, read that tag. It'll do those curl scripts, and it'll effectively delete it from here. If we refresh this, that connector's now been deprovisioned. Now I can come in here. Let's just manage tags. No. Tags. Let's remove that tag and click save. Probably should add that to my script to do that as well. So, if I want to reprovision it now, I can just simply run bin/provision. And again, I'll go through the API. It'll pull down the provisioning key. That's just waiting that 10 seconds before it goes ahead and sets the tag. And we should all be good. So if we refresh this, first off, we should have a new tag set. We can see it's updated to number 30, last number for the connector ID. And we can refresh this. You can see it's reprovisioned. We keep refresh, it'll then have a connected status. We can system CTL status ZPA connector. It seems to be up and running. We refresh this, we should see it connected. Right, it's going to take a second just to connect. Right. There we go. It will connect. It's just, as I said, dev. There we go, we're connected. So we now have the ability to build a new connector AMI. I can then export that to Azure or VMware or whatever. I can hold my API keys programmatically in Systems Manager, pull those down to any connector as I instantiate it. The connector will read, what region it's in, what VPC it's in, provided my connector group and provisioning keys match a standard naming format, which is the region and the VPC ID, then we can programmatically pull those down to the connectors. The connectors can go ahead and enroll themselves and programmatically build themselves. And then if I want to delete them, I can deprovision those programmatically as well. So I can put that in a lifecycle hook as part of my CloudFormation template. So as I scale up, they provision. As I scale down, they deprovision. I can use the same scripts, for example, if I was to build these in Docker. Docker could go ahead and read that and enroll my the containers for the app connectors, and as those Docker instances scale back or whatever, then they deprovision as well. So lots of great things and fitting in with the DevOps processes. Hope that was useful. Any questions, just let me know, mark@zscaler.com. Thank you.